Alright, this is Peter from Light Harp Industries, and I'm going to give you a little rundown of the Light Harp OS. This is the operating system, if you want to call it that, the firmware that the Light Harp uses. It is written in Arduino C, and it is compiled onto the Arduino Nano microcontroller from Gravitech, though you may be able to get it to work on other versions of the Arduino. I'm making this video mainly for Stuart McGregor, and I've tried unsuccessfully to say your name without a Scottish accent, but you know it always comes out with a Scottish accent, so I think that's the way it's meant to be pronounced. Anyway, so this is for Stu, but anyone else who wants to know what's up with the Light Harp OS as well. This first part here, these are just comments, so you can ignore them. Anytime you have a little double slash or a slash asterisk and then an asterisk slash, everything in between there is a comment. Next down here we have include files. These are part of the compiler, so they just include functions that you're going to use later. These are definitions. In this case, I'm defining offsets for various keys for transposition. So you notice that 0 is the offset for C. So basically it wants to be in the key of C, but if you add an offset of some other number, it will transpose into some other key. Number of strings, that's light strings. The current version has 7. You could build one that had more or less. Default MIDI tonic, 60. That I believe that's middle C. That's basically the lowest numbered light string. The first light string will trigger that note or that chord. Transposition offset, that is just picking one of these keys, plug it in here, and that will be the key that the Light Harp will boot to. Here's some pins. Sound out pin. This is the pin that is going to the piezo speaker, if you have a piezo speaker. That just is an error. Anyway, piezo speaker. These are the analog pins. These would actually mean the ones that are going to the cadmium sulfide photoresistors, and these are numbered A0, A1, A2, etc. on the Arduino Nano, and digitally they'd be addressed D14, D15, etc. But we're addressing them in analog mode, so we start on 0. Digital pins 8, 7, 6, 5, 4, 3, 2. The numbering of these pins will depend on how you build your Light Harp. These aren't even consistent with the schematics that I've released, so this is something you're going to want to look at and make sure that each digital pin here corresponds to the right analog pin. The analog pins are sensors. The digital pins are LEDs. So you know this one and this one got to go together. So these got to be paired on the actual device to go together, and it's going to depend on what type of hardware you're using. Here's some global variables. Oh, and as far one little note, transmit pin, which will be TX0 or on some boards TX1. That is going to go to your MIDI. Here's some global variables. These are just variables that are used throughout the program. Some of these are modes that are important to know. Piezo sound on. Make it a 1 if you want to hear beeping sounds out of that piezo speaker. Make it a 0 if you don't want to hear that. MIDI output on. 1 if you want to be able to plug it into, you know, a synthesizer or a computer or something, and 0 if you don't. And MIDI debug on, that was a diagnostic mode. You can ignore that, but it'll basically spit out a list of what the MIDI is doing at any given time. Serial debug on, this will give you a printout of of stuff that's going on that the Light Harp OS is doing. Light levels, differences in light levels, whether notes have been triggered or not, as indicated by asterisks. You cannot use this mode when you're using MIDI output. They are mutually exclusive, and it's because they use the same pin at different data rates. And if you try to use serial debug while you're using MIDI output, it's going to make everything all garbled. Chord trigger mode. This is the default mode here that will play a chord when you trigger a light string. You can toggle through that by hitting the light string combination. Right now I have it set to 3 and 4, mi and fa, but you can set that to whatever you want. That's later on. Right now I have it set to trigger a chord when it boots. It can also do an arpeggiation mode, which right now I call insane mode, but it's an arpeggiator. And it can also play individual notes. Yada, yada, yada. Not really important stuff. I'm going to gloss over some of this stuff. Threshold coefficient, threshold offset. These are variables that have to do with how sensitive the thing is. Basically, you raise these numbers, it becomes insensitive. You lower these numbers, it becomes sensitive. Scale. These are semitones above the tonic for each light string. So 0, that's the tonic. 2 is I think a minor second above that. 2 half steps, 1 whole step above the tonic, etc. This describes a major scale, this particular set of numbers, but you could change it to describe some other scale. Invert table. Now these are, how do I even describe this? These affect the thirds of each chord. So right now, the first chord is a major chord. So by taking 1 off of the third, it makes it a minor. The second is a minor chord, so by adding 1 to the third, it makes it a major, etc. You can leave this stuff alone unless you really have a need to change it. MIDI velocities. This is kind of important. This is a table that holds all the velocities in your MIDI data. Any velocity that is 0, it will consider to be a note off. Anything other than that is a note on. This is filled with current notes that are being triggered and purged every cycle. At the end of every cycle, the active notes, are copied to MIDI velocities old, and then it's refreshed, it's deleted for the next cycle. This keeps it from having stuck notes. There's an intelligent system that looks for changes between these two sets, and when a new note is added, it will trigger it, and when a note disappears, it will get rid of it. It sounds kind of convoluted, but it works really, really well. Thresholds, these are determined at the time that the system does its auto calibration, and those are analogous to the amount of backscatter that it initially receives when it initially boots up. So it should be a low number, and basically anything more than that is going to cause a note to be triggered. And there's one threshold for each light string. Triggered, this is just a binary yes or no. Is the light string triggered or not? Backscatter, this is the amount of backscatter as expressed as a number, and since it's a 10-bit digitizer, the number is going to be somewhere between 0 and 1023, though realistically it's going to be probably in the 2 digits, maybe 3. Arp len, this stuff has to do with the arpeggiator. You can make arpeggiator sequences by plugging different numbers in here.